Hello guys, welcome to Learn AI together. Now we are discuss the concept of measure of dispersion. Before we are going to another spread, in just 1 or 2 minutes we recap the previous concept because this topic is connected to previous topics only. Now we know about what you mean by descriptive stats. In descriptive stats we are doing univariate analysis. For doing univariate analysis we use the concept of measure of central tendency. In measure of central tendency we use the measures like mean, median, mode. Now we know about the what do you mean by mean, what do you mean by median, what do you mean by mode. We go through the in-depth of these terminologies, and for doing another way of univariate analysis is nothing but measure of dispersion. This dispersion is also known as measure of deviation, and it is also known as measure of spread also. So in this measure of dispersion, we know about the what do you mean by range. The range is nothing but the maximum value in our data minus the minimum value of in our data. So now we are going with the variance. Variance are nothing but spread around mean. Now what do you mean by spread of mean? Spread around mean means. So for this concept, variance is nothing but spread around mean. So now clearly we say that we take a data point and we say that this data point far away from the how much far away from the mean. So in previous video we discussed about this topic. Simply now let me write simply spread around mean. Spread around mean. So spread around mean. For this concept, for better understanding, I will take an example. Suppose we have x values like 5, 6, 7, 8, 9, and now we find the absolute deviation from the mean, xi minus mu. So now we find the deviation for this data from the mean. So when we calculate these data mean, we got the answer like 7. Mean is denoted by mu. So when we find the deviation for this data, we got the answers like 5 minus 7 is nothing but minus 2, minus 1, 0, 1, 2. So now variance is represented by single number. So variance is nothing but it is represented by single number only. Single number only. So it is not look like a single number. Now we want to make it as a single number. For this is further we need the topic of measure of central tendency. In the measure of central tendency, we use the measure like mean for doing a single number value. For this multiple values. So now for that mean is nothing but sum of observations by total number of observation. We need to do sum for these all values and divided by total number of terms. We find the average for this data. So xi minus mu by n. So we have this data. So we add this data and divide by number of values. The total number of values is 5. So when we computation these data, the negative and positive will cancelling out, remaining as an answer. 0 by something is nothing but 0. Here the deviation is nothing but 0. Means it is a spread. Is it really? It is a looking like a spread value. So 0 means no spread. No spread means no information. So now we need to do make it not as 0 as result. Means something we got the 0 not here. So now we need to make it as not 0. For that reason we need to change this sign values. So now we have two options for making it as negatives into positives. One is the absolute deviation, one is the square deviation. So when we do a absolute for this data, it is converted as negatives into positive. Positive will be same, will be here. When we do a square of this term, same it will be converted into negatives as positives, and positive will be same as positives only. Now here that it should be there. When we do a absolute deviation for this data, now everybody know about the what you mean by differentiation. So differentiation is not applicable for discontinuous function. Differentiation not applicable for discontinuous function. So when we do a absolute deviation always a discontinuous function. So discontinuous function not a differable. This is the reason why we not take a absolute deviation for this data. Now we had only one choice, that is we square up these values. Okay. Now when we square up these values, data looks like this term. We have a xi values Those are nothing but 5, 6, 7, 8, 9. When we do a deviation for this data, we appear -2, -1, 0, 1, 2. Now we want to square these values, xi minus mu whole square. When we do a square of these terms, we got the answers like 4, 1, 0, 1, 4. Now we want a single number value. For this is the reason we want we require the mean concept. So mean means sum of observations by total number of observations. We want to sum these values and divide by total number of values to get the spread of these values. So when we add it, the answer is 10 divided by 5 is nothing but 2. Here the variance is nothing but 2. Now we got the formula of variance also. The formula is nothing but variance is nothing but summation I equals to 1 divided by n xi minus mu whole square. Okay, so it is a formula for variance. Now say that here is it 2 is a correct spread for this data? It is a 2 is a correct spread for this data. For that answer, for that question, here the answer is no. For that question, the answer is no, because is it 2 is a correct spread? Correct spread for this question, definitely no, because we are magnifying the values. We are magnifying the values. So magnifying means we are squaring the values. Now we want to cancelling these magnified values. Now we want to cancel magnifying. So this is the reason we need a root terminology. Root terminology means when we do a suppose variance like 4, means variance is nothing but 4. It is a magnified value. Now we cancelling the magnified value means under root. We are doing under root for this data. Nothing but we are cancelling the value. We can write the 4 as root 2 square. Now square and magnify will be cancelled. You got the answer as 2. Now here 2 is a correct spread. It is also known as standard deviation. Means this is the reason standard deviation having the root. This is the reason why standard deviation having root. Why STD having root. Now here variance and standard deviation. The difference between variance and standard deviation. The difference between variance and standard deviation. Both are looking like same one. Here variance formula looks like summation I equals to 1 by 10 xi minus mu whole square. And in standard deviation also formula look like same, but the difference is we are adding the one more terminology, that is nothing but root. Why we are adding the root means to cancel the magnifying values. Because we need a correct spread. Magnifying value. Simply, what do you mean by magnifying values means we are doing this here. We are doing square. That is the reason. Here we are doing spread for this, square for this data. Here this is the reason. It is look like an assumption. We are taking as square. For this is the reason we need to means it is we are squaring means it is magnifying. So for this is the reason we need to do cancelling for magnifying values. That is the reason we taking as a root for this variance. So variance and standard deviation look like same. One in standard deviation, say one more thing is added, that is nothing but root. Root is added to the formula because to cancelling the magnifying values. Hope you understand. Now think we are doing descriptive stats. In descriptive stat we are dealing with univariate analysis. In univariate analysis we go for measure of central tendency and we go for measure of dispersion. Okay. In measure of central tendency we go through the topic of mean, median and mode. In measure of dispersion we go through the topics of range, variance, standard deviation. Now we want to look which one is a robust measure and which one is a not a robust. Robust means doesn't affected by outliers. If outliers are present in our data, it is called as a robust. Doesn't affected by outliers is nothing but robust. So mean is a affected by outliers, no? So it is not called as a robust thing. Mean, median affected by outliers, no. median won't be affected by outliers. So it is called as a robust. Mode is affected by outliers? No, it is not affected by outliers. It is a robust thing. Here, range affected by outliers? Yes, range is affected by outliers. So it is not a robust thing because we have the formula like max minus min values. There is a chance to get the maximum value as the outlier. There is a chance to get the outlier minimum as a outlier. So this is the reason it is affected by outliers. Now, variance is affected by outliers? Definitely, yes, it is affected by outliers because when we look into formula of variance, summation I equals to 1 divided by n xi minus mu whole square. Here we are doing some mean terminology. So mean affected by outliers. So this total term will be affected by outliers. Definitely, this total term will be affected by outliers. So variance is affected by outliers. So it is not a robust. Saying standard deviation also affected by outliers, so it is not a robust because standard deviation is nothing but under root of variance. Definitely variance is affected by outliers, no? So it is the reason standard deviation also affected by outliers. It is also not a robust. In measure of central tendency, we have a robust thing. In measure of dispersion, we don't have till now. We don't have any robust measure. So we need to. So we require. Sorry, we require one measure like we require one measure like robust, which is not affected by outliers, which is not affected by outliers. In measure of dispersion, so that is the reason comes to picture median absolute deviation. It is a median absolute deviation. So in median absolute deviation, before in median absolute deviation is a one more measure in measure of dispersion. So everybody knows about the what you mean by deviation. Deviation is nothing but xi minus mu. Now for this deviation we add the absolute. Absolute means we add the mod. When we doing a mod, negatives will be converted as positive and positive will be remains as the same, positives only. So now we need to do a median for this data. For better understanding, we take an example for this median absolute deviation. How to find a median absolute deviation means example for median absolute deviation. We having values like 5, 6, 7, 8, 9. Now we want to find a deviation for this data. So when we find a deviation for this data, minus 2, minus 1, 0, 1, 2, because mu equals to 7, mean is denoted by mu. When we calculate mean for this data, we answer is nothing but mu equals to 7. So it is a mean. That is the reason when we doing a 5 minus 7, we having these values. We are having these values. So now for this data, we want to do a absolute. We got the deviation. Now we want to do a absolute deviation for this data, xi minus mu. Now when we do a absolute time, negatives will be converted as positives. Positives will be looking like same positives only. So now we need to, after doing absolute deviation, we need to find a median of this term. So we need to find a median of this data. Before we need to find median, we are doing sorting for this data. Sorting means arranging a ascending or descending order. We want to arrange. Now here I want to arrange this data into ascending order. 0, 1, 1, 2, 2. Now we want to find a median value of this data. Median is nothing but centermost value. It is an odd case. No? We find simply centermost value. So 1 is the spread for this data. Now it is a curved spread because we don't here it is won't by affected by outlier. So median absolute deviation is a curved measure. It is a robust. So now when we look into here here we add one more measure of dispersion, that is nothing but median absolute deviation. It is won't affected by outliers. It is called as a robust thing. Now in measure of central tendency we have a robust thing. In measure of dispersion we have a robust technology, robust terminal, that is nothing but median absolute deviation. Now we end the topic of measure of dispersion. Before we ending, we know we want to one more measure of dispersion, that is nothing but IQR. That is nothing but IQR, interquartile range. IQR is nothing but interquartile range. So here we know about the term of what do you mean by range. So uh, we don't know about this term. What do you mean by quartile? That is the reason I want to cover the topic of percentile. So percentile. So now what do you mean by percentile? To understand the percentile, let me take an example. Understand the term of percentile. A person is there. He appeared a one of entrance national level entrance for MBA student CAT. He appeared a CAT examination and he got the some 99.9 percentile or percentage. It is a percentile, not a percentage. Okay. Now if somebody says if somebody says I got 5 percentile of marks versus another person says I got 95 percentile marks. In among both of them, which one is better? Definitely 95 percentile person is a better. Now, what do you mean by these values? Percentage or percentile means. What do you mean by these values? Now, what do you what do you mean by these values? These values means for this I want to take an example. These examples contains two scenario. In scenario one, a person is there. He appeared a he got the 40 out of 100 marks. Means he got the 40 percentage marks. Now think this person is a good scorer or bad scorer? Good scorer or bad scorer? Definitely he is a bad scorer because of difficulty level of exam. Difficulty level of exam. Now in another scenario, scenario number 2, this person who got the 40 marks out of 100, he is a topper of exam. He is a topper in that exam. In the exam. Think he is a perform good or bad. Definitely he performed good because difficulty level and difficulty level he got the 40 marks out of 100 and he is a topper also. Definitely he is a good person. In this scenario he is a bad scorer. In this scenario he is a good person. Means now because he is a good scorer now because everybody every remaining every student score below 40. So that is the reason he is a good scorer. Now with now here whether the person good or not completely depends upon the motion. Here 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 whether the person good or bad, that completely depends upon notion. In first notion he is a bad scorer. In second notion he is a good scorer. Okay. Now when you look into percentage, when you look into percentage, percentage, when you look into percentile in both terminologies, here you feel here when you look into percentile you feel he had bad score, bad marks. He had bad marks. But when you look into percentile, it helps helps you to understand the rank of that person. Rank of that person. Now, if somebody says now if somebody says somebody got 95 percentile marks. Now, hope you understand when we are using the percentage, when we are using a percentile. Percentile helps you to understand the rank of the person. It is mandatory thing. So in entrance level examination, somebody got the 40 marks, 40 marks, then he will be a top of that exam. By means he is a top scorer in that exam. By looking how decide means he by looking into a percentile concept. If somebody says no, if says somebody says I got 95 percentile. In this case, in this case, in this case, this person better than 95 people. This person better than 95 people. So percentile helps you to understand the rank. So now 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 so now there are some questions there. Now now some frequently used percentiles. Some frequently look into some frequently used percentiles. Now one of the some we look into some of frequently used percentile. Those are nothing but quartiles, quintiles, deciles. Okay. Now the quartiles is nothing but you need to do 4 parts. Means you need to do 3 cuts. Suppose you have something like this. You have something like for this you need to do 4 parts. Means 3 cuts. You need to do 3 cuts. 1, 2, 3. Here first cut is nothing but 25th percentile, and second cut is nothing but 50th percentile, and third cut is nothing but 75th percentile. Okay, don't confuse, it is a percentile. So now we go for the topic of quintiles. What do you mean by quintiles? Dividing into 5 parts means we need to do 4 cuts. Suppose we have something like this. We need to do 4 cuts. 1, 2, 3, 4. First cut is nothing but 20 percentile. Second cut 40 and 60 and 80. This is nothing but quintiles. Now we go for deciles. Deciles are having 10 parts. 10 parts means 9 cuts. Now here we take an example for this to understand the decile concept. Suppose we have data like 0, 10, 90, 5, 2, 6, 7 and something here 80. Now before we need to divide the parts, we need to do sort of this data. 0, 2, 5, 6, 7, 9, 10, 80, 90. Now in this data 7 is nothing but 50th percentile. It is nothing but 100 percentile. Now 10 is nothing but 75th percentile. 5 is nothing but 25th percentile. Yeah. So it is also known as median. Same here also, it is also known as median. Among these frequently used percentiles, we are most of time we are used in data science domain quartiles. So now you know about the quartiles. We go for our original concept, that is nothing but interquartile range. Interquartile range means it is an IQR. It is a measure, one technique in measure of dispersion. One measure in measure of dispersion. So now here we know about the what you mean by range. Range is nothing but the difference between max and min values. Now we know about the quartile also. Quartile is nothing but dividing into 4 parts. Now we require for this we require 3 cards. Those 3 cards are nothing but 75th percentile, 50th percentile, and another is 25th percentile. Now here when we observe this interquartile range means the maximum and minimum values in quartiles, the difference between max and minimum values from the quartiles. So now IQR is nothing but the max values in the quartile is nothing but 75th percentile, and the min value is nothing but 25th percentile. The interquartile range is nothing but this is the percentile. Okay, this is nothing but person type. So simply we can say that it is an updated version of range. Simply we can say that it is an updated version of range, because range is affected by outliers. In IQR concept, in IQR concept, in IQR concept, we fix the boundaries like maximum value, minimum value. That is the reason it is won't affected by outliers. It is some of reasons it is affected by outliers, but we fix the boundaries. So in boundaries we fix the 75th percentile and 25th percentile. Beyond the 75th percentile we got the outliers. Beyond the 25th percentile we got the outliers. Range is affected by outliers. IQR is won't affected by outliers. Some of reasons. So that is the reason we cover the topic of IQR. So now we discuss about the measure of dispersion. In measure of dispersion, we go for our measure of spread or measure of spread. Measure of spread are used in to doing a univariate analysis. Okay, measure of spread to doing a analysis. For doing measure of spread, we are using two type of terminologies. Like in first way, we are using range and IQR. In second way, we are using variance, standard deviation, and median absolute deviation. So here, when we observe range in IQR, we find the spread in between the data point. We find the spread in between data points. So here we don't require any mean. So here we don't require any measure of central tendency measure. Here when we find a spread, we need a mean concept. So here means here we find a spread around the mean. Spread around mean. So here we require the mean concept, because we find the spread around the data, how much data point far away from the mean. So that is the reason we require here measure of central tendency. Now here till now we cover the topic of measure of dispersion. In measure of dispersion, we are looking into various concepts like range, what do you mean by IQR, how it will be won't affected by outliers. In variance, how it will be so far out every data in variance, every data point will be far away from the mean. In standard deviation, in variance have a drawback. That is the reason why standard deviation comes to in picture. And these both are affected by outliers, so it is not called as a robust thing. It is a that is the reason comes into picture median absolute deviation. Simply we can say that which one is robust, which one is not. Means we observe when we observe these diagram, we can simply say that okay, range is affected by outliers. It is not a robust thing. IQR is affected by outliers. No, it is won't be affected by outliers, because we are fixing the boundaries. So it is a robust thing. So in this variance affected by outliers, yes, definitely variance is affected by outliers. It is definitely not a robust. Standard deviation also not a robust. Median absolute deviation is a robust, because it is won't affected by outliers. So we cover the almost every concept in measure of dispersion. Now let me show you. Let me show to one more way to do univariate analysis. So the way is nothing but graphical way. So everybody heard about something called like box plot. Here now I explain what do you mean by box plot. So for better understanding, I will take an example every time, an example for better understanding. Here I have an example like data. In this data I have two columns. The first column name is A, the second column is A. It is also a numbered column, it is also a numeric column. Now you want to do here you want to do some descriptive analysis for this data. So you don't worry, I am not able to understand some what you mean by measure of central tendency, how we find the measure of dispersion, how we remember the concepts of like range and variance and standard deviation. You don't worry. Simply descriptive analysis look like a box plot. It seems like box plot. But the thing is, if you have two-dimensional of data, three-dimensional of data, you can visualize. But you have a like four-dimension, n-dimension, then you go for mathematical concept only. So it is useful for 2D or 3D. 3D we are doing some 2D relationships only. We don't want to require any 3D relationships. So if we have more than 2D, two-dimension, we go for mathematical concepts like variance, finding spread, finding range concepts, finding median, absolute deviation. If we have a 2D, two dimensions mean two variables. So if we have a two variables, simply we go for box plot. If we have a smart then why we go for hardware? So simply we go for box plot. So before we going to the topic of box plot looks like this thing. Everybody knows about the box plot. So the box plot understand the couple of things. Like when we draw a box plot, it is a graph. So it has an x-axis and y-axis. So when we observe here, it is nothing but this point is nothing but 25th percentile. It is a thing. It is nothing but 75th percentile. This is a thing is nothing but 50th percentile. It is a nothing but the difference between 75th percentile and 25th percentile is nothing but IQR. Now it comes to this picture, this part, here to here. It is called as whiskers. It is called as whisker, right whisker. And here to here, it is called as left whisker. Okay. And beyond the right whiskers, we have the outliers. Beyond the left whiskers, we have the outliers. Now, suppose I want to take an example, and for this example, I have a data like this. Like I have a data like this 0, 2, 5, 6, 7, 9, 10, something, 80, 90. In the data, you can say that okay, it is an 50%. We can easily identify it is an 50th percentile. Means it is a median. No, it is nothing but 75th percentile. It is nothing but 25th percentile. Now I want to show in box plot to this values. So these data points lies on the y-axis. That is the reason box plot having the vertical region. Vertical. Okay. So now it is an 25th percentile. 25th percentile value is 5. It is an 5th value. Now it is a 75th percentile. It is a 75th percentile values. The difference between 10 and 5 is nothing but interquartile range. Okay. And the midmost term is the value is 7. It is also known as median. Okay. Now it is considered as outliers and it is also considered as outliers. Okay. How we don't require any formulas. We don't worry about any IQRs. We don't worry about any percentile things. Simply we have a box plot. It is looks like a descriptive analysis only. So now box plot, the whisker length is different. Whisker length is different. But in statistics, box plot having the same length of whiskers. But in statistics, whiskers have same length. So this whisker length is nothing but 1.5 into IQR. So for better understanding, I will draw a box plot. Now this whisker and this whisker length is same, and here to here called as a whisker. This whisker is nothing but 1.5 into IQR. This whisker is nothing but 1.5 into IQR. It is nothing but 75th percentile. It is nothing but 25th percentile. It is a whisker. So in between these, we consider as a IQR, interquartile range. Now, why only we take the 1.5? Why don't we take another values? Means for this thing, we are looking like we are look into normal distribution. When we discuss about the normal distribution, I will say why we take only 1.5 only instead of another values. Now just remember it why we take the 1.5. So till now we know about these are outliers. Now till now outliers are nothing but extremely, we know outliers are nothing but extremely high values and extremely low values. Now how do I represent in mathematical way? How do I represent in mathematically? Okay, This is an outlier in graphical way. Some theoretical way, outlier is nothing but extremely high value, extremely low value. How do I represent in mathematically means extremely high means extremely high, extremely. So extremely high is nothing but when we look into a box plot. Okay, when we look into a box plot like this, no? We have a same whisker length. These whisker lengths are having 1.5 into IQR length. The length of the whiskers are nothing but 1.5 into IQR. So we know about this is the thing is nothing but 75th percentile and it is the maximum and it is the minimum value. So it is nothing but 25th percentile. Now I want to calculate outliers. Outliers are nothing but beyond these values and beyond these left whisker values are nothing but outliers. Now I want to find a outlier. Means I know this value. Which value? 75th percentile. Now I want I know this value from here to here is nothing but length of whisker. That is nothing but add 1.5 into IQ. What is the after computation of this thing 1.5 into IQ plus 75th percentile value, 75th percentile value after computation of this value beyond this thing is nothing, which means greater than of this thing is nothing but considered as an outlier. Greater than this value we consider as an outlier. Now this outlier is nothing but this thing. Now we want to know this outlier. We know about 25th percentile as a minimum value. Now we go for left side. No? That is the reason we do a subtraction. Now I want to 1.5 IQR. We know this thing. Now here to here is nothing but the length of whisker. Above this is nothing but outlier. Now which is less than this thing is nothing but we consider as an outlier. Outlier. Now I want to calculate. I want to compute if our data has an outlier or not. For the thing, if our data point which is greater than or equals to 75th percentile plus 1.5 into IQR, which is greater than or equal to this thing, is considered as an outlier. Okay, and which is less than or equals to 25th percentile minus 1.5 into IQR is nothing but we consider as an outlier. In between the data points, it is considered as a not outliers. Okay, now we know about the how to find a outliers in mathematical way by using these formulas. Hope you understand very good. Now comes to the point. So now so now now it's I have a data like this. Everybody have a data. Some like this. In data we have a columns like A, B, C. It is a numerical column. It is a categorical column. It is a numerical column. So now everybody start for doing analysis. Descriptive for doing descriptive analysis. Analysis. Everybody know about the concepts like what do you mean by measure of central tendency, what do you mean by measure of dispersion, but they don't know where to do their start. For that, I give 3 points. I give 3 questions and answers for this thing. Now, don't worry. First, the question is you want to find an average for every column. average for average of A column, average of B column, because it is a numbered columns. For categorical columns, you find the most of frequency for categorical column. First you do this thing. Next, second thing is you need to do spread. You need to do spread. This spread calculation for only numerical columns. Okay, spread is nothing but far away, how far away are how far away are data points from me. Here the numerical columns are nothing but A and C. Now the third thing is outliers. Find outliers. If suppose outliers in our data, how to find an outliers? By using box plot. Simply go for box plot. Let you don't need any box plot for finding outliers. How do you find? Let you forget about box plot. Forget about box plot. Then how do you find? Then how do you find if our data contain outlier or not? Our data contain outlier or not. For this thing, we already find the means. Similarly, you find the median for those columns. If our data contain outliers, if our data having the outliers, definitely mean not equals to median. If our data don't have any outliers are present in our data. If outliers are not in our data, definitely mean is similar or approximately equal to median. You forget about the concept of, it is useful for you forget about the concept of box plot and spread and so on. Simply you can find the by using mean and median concepts. Hope you are understanding very well. If you are gaining knowledge from my side, please like and subscribe, guys. Please like and subscribe. Don't forget. Till now, we complete the topic of what you mean by measure of central tendency, what you mean by measure of dispersion. In next video, we go for measure of relationship. Measure of relation. This is used for bivariate analysis to doing a descriptive analysis. It is useful for bivariate analysis. Thank you guys. Please like and subscribe. Thank you.